Hi, my name is Michael King. In this second video, we're going to look at modern portfolio theory. This is going to be sections 8.5 and 8.6 out of Booth, Cleary, and Rokita. So recall that Harry Markowitz was awarded the Nobel Prize in 1990 for his work on portfolio theory, which he actually conducted in the 1950s. As we mentioned earlier, he shared this award with William Sharpe and Merton Miller. So Markowitz, in modeling this and calculating the math that went into modern portfolio theory, had to make a number of assumptions in order for his models to be tractable and to be solved. He assumed that investors are rational decision makers. This is obviously a strong assumption because we often see that investors make irrational decisions, which is a whole area of finance called behavioral finance. Markowitz also assumed that investors are risk averse, which means they do not like to take risk and therefore must be paid or compensated to take on risk. Again, this is not true. Some people like to gamble. Third, investor preferences are based on portfolio expected return and risk. And here, risk is going to be measured by standard deviation or variance. Okay, so people's preferences are going to be linked to the portfolio returns and risk, not to the individual stocks. So based on these assumptions, Markowitz was able to create what he calls efficient portfolios by combining different securities or stocks. So an efficient portfolio is one where you either get the highest expected return for the portfolio for a given level of risk, or you get the lowest risk for a given expected return. So you're maximizing one, holding the other constant, and looking for either the highest return for a given level of risk or the lowest risk for a given level of return. Recall that the portfolio risk is related to the covariance or the correlation of the securities in the portfolio. And this was the two formulas that we showed for calculating the expected portfolio risk. So Markowitz not only developed the math, he found a way of portraying it using this diagram here. The blue line is the minimum variance frontier. It is the combination of stocks A and B, which when together in a portfolio, we can look at what the expected return will be and the expected risk. So if you have 90% of A, 10% of B, you would get 1 point. If you have 90% of B and 10% of A, you'll get another point, and all the combinations in between. The efficient portfolio is going to be the one that has the highest return for a given risk or the lowest risk for a given return. And Markowitz showed that it has to lie on this blue line, the minimum variance frontier. So here we have 5 portfolios. Notice that portfolios B, D, and E are attainable because they actually lie on that frontier. In this diagram, you would not be able to actually construct a portfolio like portfolio A that has such a high return for a low risk, or a portfolio C that has a lower risk for such a high standard deviation. It simply isn't possible with the math looking at the correlation coefficients or the covariances, as well as the expected return and risk for the stocks. So we have 3 portfolios that are attainable and 2 portfolios that are not attainable. So we're just going to ignore portfolios A and C. So now that we have a choice between B, D, and E, which one is the most efficient? First of all, efficient portfolios are going to lie on the upper half of this minimum variance frontier, so the top part from E to the right, and these are going to be called the minimum variance portfolio. So that rules out portfolio D. Why? Rather than holding portfolio D, which has low expected return for a given standard deviation, you would simply want to look at the combination that would be on the upper line, which would have a higher return for the same standard deviation. The 2 portfolios that are efficient are portfolios B and E. We say that they're both efficient because they lie on the upper half of the minimum variance frontier. An investor would simply choose one or the other based on their preference for risk or return. Obviously, if you don't like to take a lot of risk, you're going to go with portfolio E. But if you're comfortable bearing a lot of risk, you're going to go with portfolio B. So how many stocks does it take to get this benefit of diversification? Well, a lot of research has been done looking at historical or ex post returns and risk. Let's take a look at this picture on the right. We see that as the number of stocks in the portfolio goes from 1 to 20, The average monthly portfolio return stays relatively constant. However, the standard deviation of those monthly returns is declining from 13.5%, which is very high, down to 6.4%, which is low. So as you can see, having a portfolio with 20 stocks, you're not giving up return, but your risk or the variability of your portfolio is going down, and this is called diversification. To make this possible, you have to find stocks that are less than perfectly positively correlated. As you add stocks or securities, the benefit of diversification is slowing down. So take a look going from one stock to two, you see a drop of, well, roughly 2.5%. Whereas going from 18 to 20 stocks, you see that the drop is only 0.1%. So eventually adding securities does not reduce portfolio risk any further, and so there's an optimal number of securities to have in your portfolio. Let's take a look at what this looks like if you were to draw a picture with this. Here we can see what happens when you build a portfolio with Canadian stocks. You can see that as you go from 10 to 20 securities, the standard deviation is dropping quite sharply from around close to 14% down to around 6%. Notice, however, that it begins to flatten out so that as you add more than 30 securities, the benefit is much less. So 30 securities looks like the standard deviation is around 6%. But once you go to 50 securities, it's just below 6%. Once you go to 100, it's probably around 5%. And once you get out to 200 plus, you're still above 4%. The insight from Markowitz is actually made up of two parts. Part of it is diversifiable risk, which is the risk that can be removed by creating a portfolio of securities. This risk may also be called unique risk, idiosyncratic risk, or non-systematic risk. What we mean is that this is the risk that is unique to an individual company. The part that's left over is called undiversifiable risk, and that cannot be removed through adding stocks to a portfolio. It may be called systematic risk or market risk. Total risk is made up of market risk plus idiosyncratic risk. Another way of saying this is total risk is made up of systematic risk and non-systematic risk. So the goal of building portfolios is to add enough stocks that you get rid of diversifiable risk and you are only bearing undiversifiable risk. And we're going to come back to this in a later lecture when talking about how to come up with the expected return for a stock. You can get a lot of benefit from adding international or non-domestic stocks to your portfolio because they are not correlated, because they are subject to different economic shocks. Notice this picture shows you that as you add stocks, your standard deviation of your portfolio return, which is shown as the black line, is going down to the point where all of the diversifiable risk is removed and you are left with the undiversifiable risk or the market risk. That's it. Good luck with your investing.